Hello, welcome back. It's Michael here, and you're watching the Joy of Code. And today we will continue with our breakout game and do something that gets quite interesting, and that is we will actually make the ball crush into the blocks and make the blocks disappear when they get hit. That is something. So finally something will start to happen when we play our game and the ball is flying around. In general, in games or simulations, of course, it's a very common problem that you want to make something happen when one thing touches another thing. The technical term for that is collision detection. So what we're actually going to look at is a method for collision detection. And pretty much all games are based on collision detection. When things happen, typically it is collisions where things happen. Even if you have a game where you shoot something at the distance, typically what you do is you have a bullet that goes along, and it's actually then the collision of the bullet with the target that makes things happen. Or if you want to walk along something, if you have a platform game, it is essentially you fall down until the character stands on the ground. Standing on the ground is collision detection. You just detect that your character's feet are touching the ground, and then that stops you from falling. Or then if you jump around, if you jump on a platform, you detect that you've landed on a platform by doing collision detection. So just about anything you do in games and simulations is based in some way or other on collision detection. Greenfoot has a number of methods to do collision detection, and we will look at one of them today, one of the simpler ones. They are all not really that hard. There are some collision detection methods that allow me to check whether I have collided with a single object, or there are some collision detection methods that give me a whole set of objects. I can say, give me all the objects that I'm touching at the moment, which potentially could be more than one. We will look at those later. They come in handy as well, but at the moment, checking for collision with a single object is enough. So let's have a look at how we do this. Okay, here we have our breakout game as we had left it in the last episode. You can download this from my blog as Breakout version 7. That is the version as it is now at the beginning of today's session. And just to see what it does, if I start this, I can move the pedal. Hitting the spacebar will release the ball, and the ball flies straight through the blocks. It is programmed to bounce off the edge of the screen, but not yet to interact with the blocks. So now we want to check whether the ball hits a block. So we will work in the ball. I open the editor for my ball class, and here look at the act method. So the act method says if we're not stuck is that we're actually stuck on the pedal still, so we're not moving. So while we're stuck on the pedal, we don't actually do anything. But if we're not stuck, which means we're flying around, then we will move. That moves the ball forward. We will make some smoke that produces smoke, and we check whether we are out. Checking whether we are out is checking whether we have gone past the pedal out the bottom. So what we add here now is we also check. I write a method called check block that checks whether we have hit a block. So that we do that after checking whether we're out, we're checking whether we maybe have hit a block. So here's the checkout method. Let's hit that. Add this here. Can be a private method because it'll only be called from this class. So we add here our check block method. There's a stub for this method. A stub is a method, the pattern with an empty body. I can start by writing a comment. We have hit a block. Okay, sorry, I can't really read and type very well at the same time, so I've just written a comment. So now, how do we do this? First of all, we have a method in the actor class. So remember, we are in the ball class now. The ball is a subclass of actor, so we have all the actor classes available. We can look at this here. If I open the actor, there we are. If I open the actor class, I can see all the or the methods of the actor. So we have here things like get intersecting objects, that gives us a list of all the objects that we're intersecting with, or get objects at offset, that gives us objects at a given offset from us, or get objects in range gives us all the objects within a given radius. Here's one, get one intersecting object. That is the one that we can use now. That is pretty much like get intersecting objects, except that if we were touching more than one object, we're getting just one of them. And that is a little bit easier to process because we don't have to deal with lists of objects. We will look at that later. At the moment, we are just dealing with one object at a time. So the intersecting object, an intersecting object is an object whose image intersects, that is, touches our own image. So I can here ask to get one intersecting object, and this method is specified in a way that if we are touching two objects, we will just randomly get one of them, and then we can make it disappear. And on the next step, at the next act step, we would get the next object that we're touching. And I can specify here a class as a parameter to say an object of what class I am interested in. So get one intersecting object, that is the method I want to use here. So I do this get, and then I use my control space, get one intersecting object, there it is, and then I can specify the class of object I'm interested in. So I can write here block.class that will, oops, spelling errors everywhere. So this will now check only for block objects. So this will check whether I'm intersecting a block object, and that will return to me the reference to that block object that I'm touching if I'm touching one, or null, a special value null, if I'm not touching anything. And that result that I'm getting back, so I'm getting actually something back here, and I should look at that again. Where was it? Just pay attention to the return value here, get one intersecting object. The return value here is of type actor, so that will give me an actor back. So here I'm getting a result back from this method call, so I need to do something with this result. The easiest thing to do, first of all, is to store it in a local variable. So I'm making here a variable of type actor that I call block, and there I'm storing the result of this method call, and I'm writing a semicolon here, into this variable. So this is declaring a local variable called block of type actor, and I'm calling a method get intersecting object, and whatever I get back from this method I store into my block variable. Okay, so far so good. Now, one thing to understand here is that there are two possible values that I will get back. Either I get back an actor, the actor that I'm currently touching, that is a reference to an actor object, and that is stored in my variable now. Or if I'm not touching an actor right now, I'm getting back a special value called null, which means nothing, which means I'm not touching anything. So I can now check whether I'm actually touching a block by checking whether my block variable contains null or not. If it contains null, I'm not touching anything. If it contains anything else, then I'm touching a block. So I can say if my block is not null, the operator for is not is written like this. A exclamation mark and equal sign means is not equal, and then null I can write just like this. So null is a special Java reserved word. It's a special value. Every variable that is declared to hold some kind of object, like here in this case actor objects, can hold a reference to an object of that kind, or it can hold null, which means it holds no reference at all. So here I can, I'm saying, if my block variable is not equal to null, then I know if it's not null, then it actually has a block in it, the block that we're touching, and then I now just ask the world to remove that block from the world. So I do a get world call, this gives me the world object, and then I say to the world, remove object, and I remove the block. That is, I'm using this variable again here, block. I'm using that variable that contains the block that I'm touching. And so here I say, okay, give me a block that I'm touching and store it in block. And I say, okay, if I actually did get a block that I was touching, then I say to the world, please remove the following block. And I specify my variable here and pass the block that I'm touching to the world and say, this is the block I want removed, please. And that is actually already the basis of the whole idea. Let's try that out. So I compile this, and it does compile, and I run it, move back, and here you see the ball, as it touches the blocks disappear. For everyone who has ever played Breakout, you will notice that this is actually a bit too easy, because when my ball touches the blocks, it flies right through them, and it then removes, let's do that again, it removes whole lots of blocks at the same time. So do that again, it removes a whole lot of them. I don't want to do that. What I actually want is when the ball hits a block, it should remove it and bounce down. So we want to actually, at that point where we remove a block, also make the ball bounce back down. We already have a bouncing method somewhere, because we can already bounce off the edges. Here we have a method called check walls that checks whether we have hit a wall, and it bounces off the walls. So here we are saying, you know, if we are hitting one of the sides, then we are inverting our X movement, and if we are hitting the top, then we are inverting our vertical movement, so our Y delta inverts. This is the way how we make the vertical movement invert. So I copy this, because this is the and I put that here. So when we check the block, if we have hit a block, we remove the block and we invert our vertical movement. Let's try that out again. Compile this again and run it. And there we are. We hit the block, block disappears, and the ball bounces down. That is it. This is pretty good. And actually now we should change the score. At the moment we get points every time we bounce the ball off the pedal. We should probably get points for every block that we are removing. This is the basis of the game is now all there. We can make it now a lot more fun by having different things happen when certain blocks are removed. You know, have special blocks that make things happen. Adding sound also adds a whole lot of fun to the game. So we'll look at all of that a bit later on. But now you have the basis of a playable game. Well, that was actually surprisingly easy this time. Fairly quick and easy, short bit of code for a really nice effect where suddenly our game turns into a real playable bit of software, and it starts becoming fun. So from now on, our game is pretty much playable, and we can now concentrate on just improving it, adding scoring, adding sound, making it more interesting, making it nicer. But this is already pretty good. So play around with this, see what you can do with it, make your own graphics maybe, make your own sound, and see how good you can make it. I'll see you next time. Bye bye.